Hi everyone, Steven here, and welcome to another MATLAB lecture video. Today we're going to be discussing variables as well as mathematical operations that are used in MATLAB. And this is really going to come down to like the crux of MATLAB and just really some of the basics, just because variables are something that you're going to have to use throughout your entire MATLAB career or anything you do with MATLAB. And mathematical operations, the sole purpose of MATLAB is to do different mathematical operations to make computation easier. So this is going to be very foundational. This is going to be the foundations of MATLAB as well as different variables. So different topics we're going to look at. We're going to look at variable assignments. Essentially, how do we assign a variable? I know I talked about this a little bit in the lecture 0, but this is going to be a little more in-depth regarding different nomenclature as well as different types of expressions you can use. We're also going to talk about different types of variables. We're going to talk about different variable functions or functions that allow us to do things with our variables. We're going to talk about mathematical operations, of course, and finally we'll end with how to use the diary function in MATLAB. So let's go right ahead. So first we're going to look at variable assignments. And so as you can see right here, the way that generally you want to use any variable, the way you assign a variable is by saying variable equals, and then you have some expression. This can be a mathematical expression, this can be a function, anything like that. But what you're going to do is you're going to start with your variable. The variable is always going to be on the left side of the equal sign. If you try doing it on the right side, and I'll show it, an example of this, it's not going to work. So an example we have is var equal 5. And I did this a little bit in the last video, but I have MATLAB pulled up, we'll do a few examples. So for example, I can say var equals 5 right here. I'm going to see var equals 5 is going to be in the output. If I try doing something like 5 equals var, you're going to see it's an incorrect use of the equal sign operator. We have to assign a value to a variable. You put the variable name on the left side of the equals bar. This may seem very intuitive, but there may be points where if you have two variables, you want one variable to be assigned as the other. Like let's say I want to assign a new variable. I cannot say, let's say I want to make var 2, for example. I can't say var equals var 2. This is not going to work. As you'll see here, there's no variable var 2. If I want var 2 to equal var, I have to start with var 2. The variable always comes first, and a way you can kind of think of this is the variable is assigned as something. So var is assigned as 5, and var 2 is assigned as var. Now we have both var and var 2 to look at. I'll clear this here. So the variable name is always on the left-hand equal sign. We can use the semicolon to repress the output statement. This is not going to be too important right now, but as you get to actually writing code and writing scripts, this will be a lot more important. So if we go back to MATLAB here, you can see if I do var equals 5, I did that originally, you can see var equals 5 is returned. But if I say var equals 5 and then put a semicolon after, I don't get anything. I don't get this clarification right here, this var equals 5. I don't get that at all. And this might not be very useful right now, but as you write code, you'll see there are a lot more uses with this, and it'll be a lot more important to include those semicolons. Variable names must begin with a letter of the alphabet. It can't begin with a number, it can't begin with a symbol or anything like that. You can't say, like, if, for example, if I try making a variable for num equals 4, for example, it's going to say it's an invalid expression. It's going to think you're trying to do for some kind of integer times another variable number, and that's not what we want to do here. So as you can see, this is not correct. They just replaced for num with 4. But let's go back. So you can't use any numbers or symbols as the first letter. Actually, to make it even more general, you can't use any symbols at all when you're trying to assign a variable. You can't use any symbols. Symbols are generally used for leaving comments in code. So if I try making a variable, let's say, for example, I want n exclamation point num, you'll see already it's going to do something weird because right now my letters aren't black anymore, they turn brown. So if I try doing some assignment, it's going to say invalid use of an operator. So this is not something I can do. But you can include numbers in your variable, but you have to include them anywhere besides the first position. So I can say num2 equals num, for example, and that'll be completely fine. Yeah, but can't contain any letters. And generally what's recommended, and this will be a lot more important as you start writing valuable code and code that's going to be put to some use, you want it to be in lower camel case. And lower camel case is basically where the first letter is lowercase and every word after that is going to be uppercase. And you don't put any spaces or underscores or anything in between the words. So for example, here we have my variable where the m is lowercase but variable, the v is uppercase. total cost, uppercase C, partial sum, total cats owned, for example. The C is going to be uppercase, the O is going to be uppercase. So the start of each word is uppercase besides the first word in that variable name. And this is going to be good. You can use underscores. Sometimes this is common. I think Python sometimes likes to use underscores, but generally to some operations may see those underscores and think that it's something else. So it's just generally better to use lower camel case when using any variables and creating variables. Now here we're going to talk about different variable types. So there's going to be 4 or 5 main types of variables that we're going to be looking at. So the first type is integers. And so an integer, in your algebra class, this is any number that has no decimal. It can be on the real number line, but it can't have any decimal in it. This is 1, 0, negative 23. As long as there's no decimal, but it can be negative, it can be 0, it can be positive, that's going to be an integer. And that's a primitive type. Primitive data type that MATLAB can deal with. And so you can see there are different types of integer type. So you can see here we've got int 8, int 16, int 32, int 64. We got uint 8, uint 16, etc., etc. So what int 8 and int 16 mean is the 8 and 16 represent how many bits are being used when storing this data type. So for example, if I have an int 8 data type, it is an integer, but it will only take up to 8 bits of data. And for anyone that's not too familiar with computer science, a bit is essentially a space in memory that can either contain a 1 or a 0. That's represented as a bit. And so if you, I could go into more with binary and all that, but that's not really what MATLAB focuses on too much. MATLAB doesn't focus too much on the data types. That's more of a computer science topic as much as an engineering topic. But so 8 bits represent 0 or 1 for each of those bits. And so when you're looking at powers of 2, that means that the largest number we can have is 2 to the power of 7. The reason it's 2 to the power of 7 and not to the power of 8 is because you can see for an int 8 type, we have to go 2 to the power of 7 as the highest, because 1 bit is going to be used for either the positive or negative sign, whether it's a positive number or a negative number. You have 1 bit of data for that, and then each other bit is going to be either 1 or a 0, and they all represent binary, so it's 2. So the first one is going to be 2 to the power of 0, then 2 to the power of 1. That's not really the most important part here. Uint is the same as int, but there's not the signed part of it, so that means that the largest value uint 8 can hold is 2 to the power of 8. Once again, this isn't the most important topic in MATLAB necessarily, but it's good introductory. So these all represent the bits that are stored. So uint type will hold 8 bits, uint 16 can hold 16 bits. Basically, the more bits you have, the larger the number you can store. And so one thing that's important is you probably generally hear bytes. So 1 byte is equal to 8 bits. So generally when you hear gigabytes or terabytes or anything like that, you're dealing with a byte. And 1 byte is equal to 8 bits. So that's an integer. A float or real number type, this is basically any number that has a decimal with it. So this could be like 23.7, this could be 0.8851. Anything with a decimal in is going to be considered a float type. And so there are 2 different types of float types. You can have either a single, which consists of 4 bytes, or a double, which consists of 8 bytes. Notice these are bytes here, so this would mean that there are 64 bits that are actually assigned with a double. When you assign any variable in MATLAB, it'll automatically be assigned as a double type, just because this has the most data stored with it. But if you are doing anything with data and you want fewer memory stored for certain variables, you can use an int 8, which will use only 1 byte instead of using 8 bytes here. Another type here is going to be the char type as well as the string type. So a char type, and we haven't dealt with this as much, this is going to be a character. So basically like the letter A, the letter B, the letter C, a symbol. The number 1 could be a char instead of an integer. And a string is just multiple chars or characters combined together. So let's take a little bit of an example. So let's, I'm going to save var, that's going to be my variable. And I'm going to save it as, this is going to be a character. So if I put A here, as you can see I put apostrophes around it and turned purple. This is going to be a character. This is going to be a character type. If I click enter, so A is a character in this case. And you can have multiple different types of characters, but what signifies it as a character is the fact that there are apostrophes around it. You can also use quotation marks. You can also use quotation marks if you want to. They both end up being character types. But so you can make a string as well. I can say var equals apple. So this is just multiple characters combined together. That's a string in this case. So we have a string, apple. You can also have characters with just about anything. One example of a character could be, let's say, a bracket. So an opening bracket, for example. That's a character because it's a single, it's just a single character. You can even have a number, but if the number has those apostrophes around it, it's not an integer type. So the one here is not an integer, it's actually a character. So if you click enter, you'll see var equals 1, but 1's not an integer in this case, it's a character type. And then the final type I'm going to talk about is going to be the Boolean type. And a Boolean is going to be a logical 1 or 0. And so this might not make too much sense right now, but going back to binary, if you think about computer or anything like that, you'll think of binary meaning 1s and 0s. And what a 1 essentially means is the value true, and a 0 means the value false. This will become a lot more important when we start dealing with conditional statements or conditional loops. But right now, this is just a certain data type that can be held. A logical 1 means true, that some statement is true. A logical 0 means false, or something is false. And there are a few ways we can assign this here. So actually going back, there are a few different ways we can assign it. We can say logical 1, actually that's just explaining it. The different ways you can go about actually creating a logical type is we could say, for example, I could say var equals true. And when I type true, MATLAB doesn't take that as a string or a function or anything like that. It legitimately thinks true, a true variable type, or in this case, a logical 1. And a Boolean and logical type are the same thing. If I say var equals false, it's going to say var equals a logical 0, or in this case, false. And these are going to become a lot more important when you're dealing with more complex types of code. But so for right now, they don't mean too much, but this is definitely something to keep in the back of your mind. So those are different variable types. Now we're going to look at different functions for variables. So many of the variable types that we discussed earlier have their own functions to actually make it a variable of that type. Like I said earlier, when you assign a variable in MATLAB, specifically any number, MATLAB will automatically make it a double type. And the double type was a floating type that stores 8 bytes with it. But so you can make it any type that you want. Here are a few examples that we can try out right here. So let's try out the first one. So a equals int 32 of 23. So the a is going to be the variable name in this case. 23 is the number we actually want to be stored there. So 23 is the number we want. But we don't want it to be a type double. We want it to be a type int 32. So we can say a equals int 32, 23. And so you can see instead of just saying a equals 23, it's going to say a equals int 32, 23, telling us specifically that int 32 is the variable type we have here. Let's see, we can also say b equals uint 16. Remember, uint means an unsigned integer, meaning there's no positive or negative, meaning it has to have a positive value in this case. So uint 32, what was the type we had here? Uint 16, 78. Uint 16 of 78. So you can see B has a uint 16 type here, and the value is 78. Back here, C equals double Y. So C equals, so this is going to be actually an important concept. Let's see how we really put this. So Y is actually a character in this case, but we're using the double, meaning we are going to get a double number out of it. This might not make any sense, but if you click enter, it gives us a value of 121. And there's a specific reason for this, and the reason being that all characters in strings are represented by what's known as the ASCII primitive type, or ASCII. And ASCII, I think maybe I had it written down, but I skipped over it. So ASCII, that stands for the American Standard Code for Information Interchange. And so essentially what that means is that every single character has a specific integer value associated with it. So that means that if you go back here, the lowercase y has an integer value of 121 associated with it. And every single character has a number associated to it. So let's take a look at a few. Let's say C equals double, let's go with an uppercase A in this case. An uppercase A has a value of 65 according to the ASCII data. If we try, and it is case sensitive, meaning that uppercase and lowercase characters are going to have a different number associated. So if I say double lowercase a, it's 97. We can do this with a lot of different types. We could do it with just actually a space. A space actually has a number associated with it, and that number is 32. We can say, let's see, double, let's try the number 2 as a character. It's actually not 2 in this case. The number associated with the number 2 as a character is a 50. This is basically just because MATLAB as a language can't just understand characters. It has to have a number associated with it. So it has the number, and MATLAB can tell, okay, this is the number associated, so it must be this character. It's very down to earth. It's not going to be the most important when it comes to writing your own code, but it is something to know. Let's go back here. D equals char 77. Likewise, we can go the other way. We can say D equals char. So this is asking us, okay, what ASCII number or what character is associated with a 77 according to ASCII? If we look here, it's going to be the capital M. So that means, so if we go the other way around, if I say C equals double capital M, the number associated with it is 77. They go together, they correlate. Let's see, the final one is E equals Boolean 0. So I can say E equals Boolean 0. This is going to give me a logical 0. If I were to say E equals Boolean 1, that's going to give me a logical 1. True. And with the Boolean function, it actually works that if you enter any number that isn't 0, it's going to return a logical 1. So if I said E equals Boolean, if I put like 54 in here, it's still going to give me a logical 1. The only way you can get a logical 0 is if you enter 0 in Boolean. Another function that works, it does the exact same thing as Boolean, it's just logical. So if I say logical 0, I get a logical 0. They both work the exact same way. Some functions are used to display information regarding the variables that are currently on your workspace. So if you look in your workspace, we have all the different variables that we've been working with. If I were to type who's going to actually just list out every single variable that I currently have on my workspace? You'll see I have A through E, num2, var, and var2. If I were to, I can use a function that's even more specific. This function is whos, W-H-O-S. This is going to give us a little bit more information about these variables. If I say whos, now they list out all of them in a column. They tell you the size of this variable, meaning what are the dimensions of what we're working with. This goes back to matrices, and this is going to be discussed in a later video. But so the size, since they're all just single numbers, they can be thought of as a 1-by-1 matrix. So all of them are 1-by-1 matrices because they're all just numbers or a single character. And so this actually tells you all the bytes that are stored by each of these. And they actually make sense if you look. So the class or the type we're dealing with here is an int32 type. 32 means 32 bits. Since there are 8 bits for every byte, 32 divided by 8 means there are 4 bytes, which completely makes sense with what we have here. If we look at variable b, we made that a uint16, meaning 16 bytes. 16 divided by 16 bits, I apologize. 16 bits, 16 divided by 8 is 2 bytes. Double always has 8 bytes. Char will always have 2 bytes in this case. That's always just common for char. Logical, since a logical is just simply a true or false, it's going to be stored by only just 1 byte in this case, which is what we have here. Doubles 8, logicals 1, just like what we were going. So you can see, so you can find everything. Attributes. So this goes back to, this goes more towards classes, which is more of an object-oriented programming approach here. We're not going to discuss attributes in this case. It's not really something you're going to need to worry about for purposes of this course. So let's see. And then the last one, this was one I discussed previously, was the clear function. And what clear does is it just removes every single variable you currently have on your workspace. So you can't use any of those variables anymore, but it clears up some memory. Now we're going to talk about some of the mathematical operations. So in a previous video, I talked a little bit more about adding, subtracting, multiplication, division. I talked about exponents, which was the caret, which was like right here. All those can be performed on integer types as well as float types, meaning that you can't do these on a character. And we're actually going to have a little bit of an example. If I try adding, let's say I try adding two characters together, for example. Let's say I want to add B and I want to add E. Let's say I want to add those together. Let's see what happens. It gives me 199. And so maybe the way you're thinking about this is like, oh, okay, B plus E, maybe I was going to get the word B, BE. That's not what happens in this case. What actually happens is it ends up taking the double value for B, which you see is 98, and it adds it to the double value of E, which is 101. If you add 101 to 98, you get 199. So you can't just add characters. This is the same for strings. You can't add them or use mathematical operations like you would with integers or float types. Some more mathematical functions supported by MATLAB. They have sine and cosine on here. You can take the sine of a number. Sine is specifically for radians in this case, so you have to know, you have to use a radian in this case. So I can say sine of, some radian. Let's say I say 0.1223. the sign of that number is going to be about 0.12269. And so specifically, you have to use radians in this case. So I could use radians generally deal with pi, so I can use pi. In this case, MATLAB actually has a variable saved for pi. If you just type the word pi, MATLAB automatically has it stored as pi to pretty good precision here. So I can say sine of pi, and sine of pi should come out as, so this number here, you can see if, for people who have taken like pre-calculus or trigonometry, the sine of pi is obviously 0. But so MATLAB has a certain accuracy that comes with it. And so if you look at this number, it's 1.22 times 10 to the negative 16th. We can say that's essentially 0. And so MATLAB also has cosine. So if we were to do the exact same thing for cosine, I can say cosine pi. This one comes out to -1, which is exactly what it was. I could say cosine of 0. It could be 1. You can actually use degrees if you want to. Another function that exists is sine d. So sine d is actually the sign of degrees as our input. So if I enter 45, it's going to come out as 0.7071. This number is going to be more commonly recognized as the square root of 2 over 2, which is what the sine of 45 degrees is. Cosine has the exact same property. Cosine d of 45 should give you the exact same number because it's a 45, 45, 90 triangle. So sine and cosine, right here we have functions REM and MOD. This is going to stand for remainder and modulus. And so remainder is essentially the amount that's left over, an integer value that's left over when you divide two integers. So if I were to say remainder 9, 2, and you have to use a comma in this case. So I'm going to say, okay, perform 9 divided by 2, how much is left over? And so this kind of goes back to, I don't know, 3rd or 4th grade. The amount that's left over is 1, because you do 9 divided by 2, it goes evenly 4 times, and you have 1 left over. Mod is used the exact same way. I could say 9 divided by 2, and how much is left over? So I do mod of 9, 2, I get 1 left over. 2 goes into 8 4 times, and then you have 1 left over. Let's see, we also have the exp function. This is used for an exponent in this case. So let's say I want to say exp of, I could say some number, let's say 2. So I end up with this, and it might be like, okay, how do I get this number? Well, when you use exp, you are actually performing the operation e to what the power of whatever number you decide to put inside the parentheses. So what's actually happening here is e squared, and e is 2.71828 or so. So if you square that number, you're bound to get this. Likewise, MATLAB also has a log function, and log, generally people, when you hear log, you think of log base 10. MATLAB considers log of log base e, or the natural log. So if I were to say log of, let's say some number here, if I say log of 10, for example, it's not going to give me 1 like one would think. It's going to give me 2.3025, meaning that e to that power is going to give us 10. If you want to do a different base with log, you have to enter 2 numbers. The first number is the number you want to take the log of. The second number is the base. So if I did want to do log base 10, I would say log 10, comma 10, meaning it's log 10, but the base is 10. The base is the second number here. And whatever website I looked that up was actually incorrect because it's not allowing us to do that. So unfortunately, that's actually not supported by MATLAB. So instead, what you'd have to do, unfortunately, is you would have to do the change of base formula, meaning I'm going to do log of 10 divided by log of 10, if you want to do log base 10. The change of base formula is where you just use some logs. So let's say I wanted to do log base 2 of 8. I would have to say log of 8 divided by log of 2 for log base 2 of 8, and that will give me 3. You're going to have to do that with MATLAB because you can't just do other bases, unfortunately. So that's with log. Now we have a few rounding variables or functions here. We have round, ceil, floor, and fix. So round simply rounds any decimal that you have. So if I'm rounding a decimal, let's say round, like you would commonly think. So let's see, 6.45. Since the decimal is below 0.5, it's going to round to 6. If it's above 0.5, so let's say I have 6.52, it's going to round up to 7, just like common rounding techniques here. So we have that. Ceil is just going to round whatever number you put in to an integer that's greater than or equal to that number you entered. So it has to be an integer greater than or equal to, but it's going to give you the nearest one. So if I said ceil, it's for ceiling, of 5.3, it's not actually going to round to 5 in this case. It's going to round up every single time. So round up to 6. The only time it won't round up an integer is, let's say I just put 5. Since the closest integer greater than or equal to 5 is 5, it's going to give us 5. Even if I were to put 5.00001, it's still going to round up to 6 because it'll always go up if it's even a little bit above 5. Likewise, we have one that works very similarly, which is the floor function. So this one's always going to round an integer that is less than or equal to whatever you put in. So if I say floor, and just to kind of demonstrate this a little bit better, let's say I put 3.99, it's going to round to 3, but let's say I put a negative number in this case. Let's say I put negative 5.23. So it's not going to round to negative 5, it's going to round to negative 6, because negative 6 is less than or equal to negative 5.23, and it's the closest integer. So it'll round to negative 6. The last one to look at here is going to be the fixed function. This one's going to round the nearest integer closer to 0. This sounds a lot like floor, like, okay, it's always going to round closer to 0, unless you think about negative numbers. For a negative number, it's going to round up. It's going to round closer to 0. So to demonstrate it, if I were to say fix, or to say 3.4, it's going to round to 3, because it's an integer that's closer to 0. But if I were to say fix of negative 6.5, it's not going to round to negative 7, it's going to round to negative 6. So depending on whether it's positive or negative, fix does something different. So those are a lot of the different functions, the mathematical operations that are supported by MATLAB. So I have an example here that we can look at, just dealing with data types and dealing with some functions. So it says, store the result of taking the remainder 34,521 divided by 23, so taking the remainder of that operation, and store it as a variable named remainder variable. Make sure the variable is an unsigned integer type that holds 4 bytes. So we have a few things to look at. First, we need to find, okay, what actually is the remainder of 34,521 divided by 23. So that's something we can do on MATLAB. So to actually do that, we're going to have to go back and use one of our functions here. So since we're taking the remainder, we're going to use one of these functions here. We're going to either use remainder or modulus. Both of these do the exact same thing. Let's just use REM because it sounds like remainder. So if we go to MATLAB, and I believe, let's make sure I have the correct number, so it's 34,521 divided by 23. So to do that, let's store some variable, let's just say temp. So some temporary variable named temp is going to be, and we're going to take the remainder of this, and it's going to be 34,521, and we're going to divide it by 23. So remainder always works free of 2 inputs, so we say 34,521, comma, 23. Temp is going to equal 21. So 21 is the remainder of doing this operation. But now we're not completely finished because we want to store it, as the problem says, we want to store it as an unsigned integer type that holds 4 bytes. So the type that holds 4 bytes, if we go back here to our variable types, so we want unsigned integer type, so that's going to be one of these UINT for unsigned integer, and we want one that can hold 4 bytes. Well, all of these numbers here represent the bits, and we know that 1 byte equals 8 bits, so since we want 4 bytes, that means we're going to be dealing with 32 bits, meaning that this is going to be the that's going to be the expression we want to use, the function we're going to want to use here, UINT32. So if I go back here, I can create a new variable, and the variable name that we wanted was remainder variable. So I can say remainder variable equals, and then I'm just going to say it's going to equal temp, but we want to make it a UINT32. So I can use the UINT32 function. We can use our temp variable in there. I could put 21 if I want to, but I can just directly put that temp variable we have. And now we have our answer. We have the remainder variable saved as a UINT32, and it's going to be 21, which is what we wanted. So now we were able to do this in 2 separate steps, but you can also do it in 1 step. You would just have to use some parentheses. So I can say remainder variable equals, and so I could put the UINT32 first around this whole expression. And then on the inside of this, I can put the remainder of 34521, comma, 23. And then I put one variable to close the first function, and another, not variable, parentheses, put another one to close the second function. And this will give me the exact same conclusion. So this is really just a simple exercise just to help deal with data types and mathematical operations. So the last thing I want to touch on is going to be the diary function. And so this is going to be a function that uses the MATLAB can basically do to record what you put in your command window. So it says all variable assignments and functions performed in the command window can be recorded using the diary function. The way you start that is you begin by typing diary and then whatever the name of the file you want to be, and then you click enter. So let's look at MATLAB here. So since we're going to be actually storing a file here, I'm going to store this somewhere else. So I'm going to go to my diaries folder that I have. So I'm going to make sure that this text file that appears actually is saved in my diaries. So I can say, let's say I put diary, and I can say example diary.txt. This is going to create a diary called example diary.txt. So nothing happened at first, but let's say I make some variables. So I can say var equals 5. I can say 3 plus 5, answer 8. I can say var minus 45. I can say remainder of 32 divided by 23 gives me something. I could say, I don't know, sine of 34 gives me that. So I put all that stuff. Then if I type diary, the next step here, let's actually see. So it says proceed with any activity as normal, and then finish by typing diary off. So if I go diary off, it looked like nothing happened, but then if you look in the corner here in our current folder, we actually have a text file that appeared. If I click on it, you'll see that this actually appears in what's known as the editor. This is where you can just edit or create code. So you can see everything that I typed is saved as this .txt file. And so what's really nice about this, I'm going to exit out of this for now. What's really nice is I can go back and I can return to this diary, even though I ended it. I can return to it right where I left off by just typing the diary name of the file again. So if I type the exact same thing, so diary example diary.txt, and then I say v equals 456, w equals 3, and then I say diary off, and then I click on this again, you'll see that new stuff I added on the bottom just got attached to it. So this can be useful. Your professor might ask you to make some diaries, and this is going to be exactly how you go about doing that. So that is going to be all for this video. Thank you. Feel free to email me if you have any questions. This is going to be strictly for UNL students. And thank you.